We're going to look at isotopes in this video. Isotopes are different types of the same atom, and they have to do with the number of neutrons. We know from a previous video that neutrons don't have a charge, but they have a mass. So they're one of the particles, along with protons, that's responsible for the mass of the atom. So we're going to expect these atoms, these different types of atom, to have different masses. But neutrons don't affect the way that atoms react. So this isn't going to be to do with atoms that react in different ways. They're just going to have different masses. So if we look at this example here, we've got three different types of carbon atom: carbon-12, carbon-13, and carbon-14. So these are the same element, but they have different mass numbers. That's what this number is showing. And that is one of the definitions of what isotopes are. They're atoms of the same element that have different mass numbers. We can look at the number of protons and the number of neutrons that each of these has, because we know that the mass number tells us the number of protons and neutrons combined. So first of all, if we look at the number of protons, these are all carbon atoms. If we look at the periodic table, carbon has an atomic number of 6. So these have all got 6 protons. That's what makes them carbon atoms. Number of neutrons then is going to be our mass number, take away the 6 protons. So this carbon atom has 12 take away 6. It has 6 neutrons. This carbon atom has got 13 take away 6, so it's got 7 neutrons, and this carbon atom has got 14 take away 6, it's got 8 neutrons. So we can see here another definition of what isotopes are, and the reason why they're the same element with different mass numbers. They're elements that have the same number of protons. But they have a different number of neutrons. So this is our other way of defining what different isotopes are. They're atoms that have the same number of protons, but a different number of neutrons. So we'll find that for our second example. This is two types of chlorine atom. So we've got chlorine-35 and chlorine-37. So again, number of protons will always be the same for a chlorine atom. It'll be that small number, 17. So this and this atom have both got 17 protons. And the number of neutrons will be the mass number take away 17. So 35 take away 17 is 18 neutrons for this chlorine atom. But 37 take away 17, 20 neutrons for this atom. So same number of protons, but a different number of neutrons. Okay, last question is, what is the relative atomic mass, which is shown to us on our periodic table and has got often a number that's not a whole number. Why is it that we aren't given a whole number? That's because the relative atomic mass shows us the mean average mass number for all of the different atoms of that element in the universe. So for example, if we look at chlorine, we would find that about 3/4 of the atoms in the universe are chlorine-35, and about 1/4 of them are chlorine-37. There are just a few other types of chlorine atom as well, but they don't last very long. These are the main ones. So we're going to expect to find that the mean average mass number will be somewhere between these two, and because there's more of Cl35, it would be closer to 35. And that's what we find. If we look at chlorine, it's 35.5. So that's our mean average mass number for all the chlorine atoms in the universe. If we look at carbon, it's a strange one. If we were to look at our periodic tables, given to only one decimal place, it's 12.0. If you had it to 2 decimal places, it's actually 12.01. So it's very close to 12, but just slightly above. And that's because almost all the carbon atoms in the universe are carbon-12. There are just a tiny, tiny number of them that are carbon-13, and an even tinier still number that are carbon-14. So therefore, the mean average mass number for all the carbon atoms in the universe is very close to 12. It's 12.01. So that's the definition of what isotopes are and what the relative atomic mass is.